I guess we could start, Ronald. Do I
Yeah.
have your signal? Okay. So, good morning, everyone. I would like to warmly welcome every single attendant of our event. As you probably know, because you have obviously fully aware signed to be here, we are going to check if one of the electronics industry manufacturer is a good place for the mobile robots. Mobile robotics is a technology that must meet several requirements in the factory floor before the real application is deployed. Of course, the real visit is not possible due to the times that we are living in, but what if I tell you that we are ready to make it fully online? This is why I invited an expert in mobile robotics, the technical jack of all trades, Ronald Olex from Mobile Industrial Robots. Hi, Ronald. It's really nice to have you here.
Hey,
Couple of words for you.
hey, Lucas. Thanks for invitation. I know that you've been doing started this podcast concept, etc., with ProGobot, and it's really fascinating. And I'm glad to take part today.
Okay, just a quick start in terms of Denmark. So it seems that if you give the Dane a piece of metal and a computer, it is very likely that he's going to make a robot out of it. So how it is? How is it that the Denmark is the capital of robotics? So maybe a little in terms of that.
Yeah. So it seems like it's in terms of collaborative robotics, Denmark has really put a mark on the map, so to speak. We have here the city where I'm living in called Odense. It's a city of 200,000 people, so it's not so big per se, but in this city we have something called um, a concept called Odense Robotics, and it is a cluster of companies, working with robotics. Let's say doing either robotic arms or grippers or autonomous robots. So it's in total, I think, over 130 companies over here working together towards the same goal. And yeah, we have, according to the information I could find from the internet, it's around more than 4,000 people hired in this robotics hub here in Odense. So yeah, it definitely seems like if you give the Dane some kind of a computer and the tools that are needed, then something is going to come moving autonomously. That's for
or
sure.
even if not moving, there at least a gripper, I guess. So,
Well,
but still moving,
yes,
still moving. You have a point. You have a point.
either it's moving or it attached to the moving part, but
Yeah. Yeah.
it will
So
be useful.
thanks for the short introduction. So briefly, I could say that you are just a robotics Google, I guess, like the top engineers, top-notch companies, top-notch products and technology. So why not to call it like that for me?
Yes, in terms of we have here, universal robots, mobile industrial robots, and all our partner systems are, or a lot of the partner systems are located in here, who are making the products and or the add-ons for the robotics.
Yeah.
Yeah.
Yeah. Yeah, okay, so we talked about your company. Now a little about you. So many applications, many factories, many robots. Generally, a lot of experience in helping to implement those applications with mobile robots. So I would like to start by presenting all the benefits of the robots in general. I think there is no better person than you to make a preview of
Mhm.
that. So if you could have a go.
Well, I can definitely get started. So I work at the company Mobile Industrial Robots, where we produce autonomous vehicle platforms that are used, let's say, in different kind of industries, manufacturing or any kind of industry where goods are need to be transported from A to B. And all in all, I mean, deploying a autonomous robot has many advantages. The most fastest ones are, or the most how to say obvious ones are that it shortens the lead time A to B. The robots can be programmed to take the best route to reach the destination, and it will always take that route. What you instruct the robot to do, that's what it shall do. So customers have full overview how they want to customize their product movement inside the factory, etc. So have full control over it. Maybe another factor would be that the robots, they actually free up employees for much more valuable tasks. If maybe today you have 2-3 people who are let's say employed and moving a cart A to B or transporting goods, then if you would have a robot, he could do this job without breaks, without anything, and you could maybe assign two people to work in some other critical area in the factory, and maybe one person will get to be in charge of the whole robotics process in the factory, for example. So it creates a really nice environment for the employees. I have seen a lot of times on site where it's people are really happy to work with the robots. They like to program them, and it makes a day a bit more interesting, so to speak. So it maybe makes the work environment a bit better, and at the same time safe as well. Robots have their safety system all around it, so it's a safe product to work with, I would say.
Oh, okay, Ronald, is it true that sometimes the clients are managing to program the robot by themselves? They are not even hiring a third-party company, and they are just doing it by themselves. So do you have cases like that?
Basically, yes, I would say that. Let's say when customer buys a robot from us, it arrives in the factory. You take it out of the box, you turn it on. I would say that depending, of course, how big is the facility, but within half an hour you have it programmed going A to B. Of course, you need a bit of a basic training just so you know what you can do with it and where are all the buttons in the interface, etc. But you don't need to be a certified programmer to program mere robots. That's for sure.
Okay. So if we know the benefits of the implementation of mobile robotics being deployed in the factory floor, I think that we could actually go to the case summary when we are actually going to talk about our client, dear client that has accepted our mission to make this event based on their layout. So let's start. So we as a ProCobot are observing that clients are getting really more and more interested in the robotization of the internal logistic, especially now after the hard times has arrived, of course, due to the corona pandemic. And even one of our potential clients decided to make an online analysis of their factory floor regarding mobile robotics. So now I'm waiting for an interview from you, and I'm really ready to ask all your questions about the client and
I mean,
layout.
it definitely makes sense. Why now is it's always the time to do something, but why now is really the time to invest in your automation of your factory, because what this pandemic has shown us is the demand for goods goes up and down. So with robots you can either pump up the volume or pump it down, assign
Yep.
robots to different
You
tasks.
you can adjust. You can just adjust it, yeah, up
Yes,
to your
yes, yes.
production volume and so
And
on.
then yeah, if you, I read an article where it said that this pandemic is even not the worst thing. For example, distributing the
Yeah,
vaccine on the global scale might be one of the toughest, let's say,
logistic.
challenges for the 21st century logistically.
Yeah, like logistic
So,
mission for sure. It will be really tough and hard to distribute it, in one time that everyone gets it and spread it around the world. But yeah, so
yeah.
if it comes to our client, any
Mhm.
questions about him? What would you like to know?
Many questions. Like I always ask you, if you come with me with this question, I would like to know who is the client, what are they manufacturing, etc.
Yeah. Due to the obvious reason, no names, but of course, it's the
Okay.
electronics industry manufacturer,
Mm-hmm, mm-hmm. Okay.
basically.
And is this Is this a factory in Poland?
It's factory based in Poland, yes. Actually, they are making cabinets and the test stations. So basically, electrical and automation components assembly. That's the process of it. That's what they are
Okay.
actually doing. Hmm?
And does the client have? You have been on site, right? Because,
Yes, I were there. Yeah.
how was the environment for the robots, and
Oh,
what does the
okay. So
client really have in mind?
that's a really pointy question. So yeah, in terms of environment, it is clearly dynamic, I would say. People passing by, and of course a zone where you can even find the forklifts. So I don't know if if in your language I could say it's dynamic, but when I was there, for me it was kind of dynamic due to the people and the forklifts that were moving and operating also in the same area. So yeah, I would say it's very dynamic. And
But
Ramel,
you said they are producing the cabinets. Would the robots need to move, let's say, between assembly lines or like the main routes inside the factory?
actually, I'm just going to share my screen to show you the layout with the stations that are on site, but I would like to mention one more thing, because this case has another catch. You know, it's electronics industry, so there is ESD required. So how about that? Are we going to manage somehow to match this factor?
This this we can accommodate for sure.
Okay.
We have, for example, MIR 200 and 250 are fully ESD protected. But that brings us to another question.
Okay.
What is the payload that the customer needs to transfer?
In the peak, we have established it would be something like 45 up to 50 kilograms, but it would be at the peak. So I would expect even lower payloads, but of course the 50 or 60 is the peak one.
Oh, that's really not the problem. We have robots for up to 1,000 kilos. So 50 kilos for electronic industry EST protected is really at the core of what we can offer.
Yeah, perfect. Okay. So I guess I should now show my screen with this. Okay. So
Yes, it's in here.
do you see my screen?
Yes.
Okay.
I hope everybody else can see it as well.
Yeah. So if it comes to just a second, does it work? Yes. If it comes to the specific points we could show, there are actually two of them. So one, I'm just going to mark it. One is the tool magazine, where the people go to get the necessary tools and stuff for assembling, and the second one is here. And the second one is just the screw magazine, which contains a lot of screws, which of course are required for almost every manual operation in there. So yeah, basically we have two clue points to think about. So maybe to explain it, let's say more, I'm just going to say that in terms of this tool magazine, so we are going to handle that one. People are assembling a cabinets. Of course, people are assembling the cabinets over here, and here. So we have three stations where the people are, screwing everything and assembling all the test stations and the automation cabinets, as I said before. Okay. So like I said, people are assembling a cabinets with a wide range of tools, and beginning with hammers, torxes, like screwdrivers and all other stuff. And they basically need to stand up every time from their assembly station and just go there to grab some tools. Of course, as people, we can suspect that there are some times that they are even forgetting some tools and they need to go one more time there. So yeah, for me, highly ineffective. So that is regarding the tool magazine. Now let's jump in the screw magazine. Yeah, apart from the tools, of course, the necessary stuff for this assembling are screws, which should be distributed at least once would be good if it would be twice an hour. So every station should be supplied by the robot twice an hour. Okay.
Mm-hmm.
No, now the people are just coming and need to take a box and pack some screws and go back to their assembly station. Yeah.
Mm-hmm.
So that's how it looks like from this layout. Uh, what is more, actually, people, you can see like the yellow lines over here. This is the
Mm-hmm.
zone where actually the robot could face a forklift.
Mm-hmm.
So it's a shared zone actually. So
Mm-hmm.
every every everywhere here people are passing by, but this yellow zone is actually where you could find a forklift, a manual forklift that people is just pushing.
Ah, the manual one. Okay.
The
Okay.
manual one, but still I'm a little bit concerned that it can be tricky for the robot, but I'm just waiting
Mm-hmm.
for your question here. Right.
Mm-hmm.
So is it enough for you in terms of analyzing the layout, or you need some more input values?
Oh, this gives a really nice overview. I can see the layout doesn't seem very complex. There's basically an empty area there in the middle, in the yellow area, etc. Right?
Yes, yes.
Okay. And let's say if people are working at the stations, would there be a lot of people also walking around still? Let's say if they are not going to pick the screws or tools anymore.
As you can see, the station, the red square here,
Mm-hmm.
it's divided in two smaller squares or rectangles. Actually, one people per one side. So you have two people in each station. Of
Mm-hmm.
course, it's not a standard. You can of course meet just one person assembling the stuff there, but yeah, there are two places actually for two people. Yeah, so we can
Mm-hmm.
suspect the maximum amount of people in one station could be up to two.
Okay.
Yeah.
Okay. And did you notice? Do they also have already some kind of a network coverage, let's say for Wi-Fi, etc.? Because it's when it comes to if they want to do some integration later on, the site needs to have a pretty solid network coverage.
Uh, Actually, we have checked it. The coverage and the bandwidth was the parameters were very good, but they, of course, for now they don't have the separate network. But I think it's like the separated network is not being done yet. But I think it's not a problem. Like it's the
Mhm.
yeah.
Okay, okay.
If it comes to coverage and everything and the bandwidth, everything was very very good in every place of the layout that we are now showing off.
Mhm. And okay, so the payload was, let's say, 50, 60 kilos ESD protection. I see this two options, two robots, either a mere 200 or a 250.
Yes.
That's what I think so.
What could be the choice? Yes, here.
Well, I think both choices are great. Both robots apply to here perfectly. I guess if it's a new customer hasn't worked with robots yet, then
Yeah, yeah. Sorry,
probably I would.
I forgot to add that the customer doesn't have any single mobile robot for now, so
Mhm,
completely not robotized client. So that's
mhm,
also a very important, I think, parameter for now. So
mhm,
okay,
mhm.
go on. Sorry.
I mean, if you have here options for a mere 200 or a mere 250, then I would lean towards the 250 because it is newer. The design has been improved, like the design elements a lot. It is many years newer than the 200, and it's also faster. Plus, I think it has some great applications that you can build on it.
Okay, Ronald, I'm just a little bit concerned one more time about the zone where you can find the manual forklifts. How you could explain how the robot could see the forks of these machines to avoid collision with that,
Mhm,
because I
mhm,
know they are going really low on that,
mhm, mhm,
and it's a really common problem. generally in mobile robotics, because I've been talking with a lot of vendors of the mobile robotics manufacturers, and they claim that detecting the really low based things is really tricky. So I just wanted to make sure that the robot doesn't drive into the forks and make more troubles than the positives. So what about that?
Well, I would say that low forklifts placed whenever is definitely a hazard. Robot, it has in front 3D cameras that can see low objects, let's say around 5 centimeters. You can also dim it a bit to see a bit lower. So if the floor is good, then this height where the cameras see can be adjusted just a bit to match on the floor to see as much as possible. In addition to that, just because the client is very concerned about these forklifts, I will recommend the 250. And that is because it has a better sensory system all around it. So it basically has two sensors, proximity sensors on each corner, which have been calibrated to detect any object that is a bit higher than the floor. So if robot would drive very close to the forklift, then it will stop because it has detected something on the floor.
Yeah,
But generally, you are totally correct. When you're deploying the robots, then my my suggestion is to view anything that is under the height of the laser scanner. So anything under the 20 centimeters should be considered as a potential hazard in the risk
okay.
assessment of the
Yeah.
application.
I had a really interesting chat with a professor in one of the Polish universities, and he said that the problem is that actually, when you're actually reading all the environment for the robot through the scanners, laser
Mhm,
scanners, of course, because most of it, I could even say like 99% of the robots have the laser scanners. And what is maybe not the problem, but the issue is that they have the fixed position. So everything
mhm,
what is lower, as you said, cannot be visible. But you said there are proximity sensors, there are cameras. So let's say a lot of equipment that can actually grab the data around the robot, not only the scanners that are fixed
mhm,
on
mhm.
a specific position. So okay, for me it's
So
answered. So there are cameras, two cameras
basically, yes, yes, yes.
and proximity sensors. Yes. Okay.
Yes, and for cases like these, mm, the factories I've been visiting, setting up applications. The first thing is to test all the sensory system regarding the forklifts, etc. But it's also very important always to put in place some rules, let's say for the operating environment when you're deploying robots, because of course robots are autonomous; they can plan themselves around dynamic obstacles, etc. But to have the fastest times from A to B, then it is always required to set some rules. And therefore, let's say if you have a lot of hand forklifts in the factory and the robots driving also around the forklifts, then you should place on the floor, let's say, the parking areas for the forklifts, which you can then mark as a, let's say, a forbidden zone for the robot, so robot will never drive in there. So it is all about minimizing the risk of these things.
Uh, I have seen that people are already posting questions, which is very good, but I would like to explain how we would like to handle those. So at the very end of our video, when we are going to make those analyses, we are going to ask all the questions. One of the, let's say, questions that should be answered right now is from Grzegorz. So the robot doesn't see forklifts forks. No, as we said, with only scanners the robot wouldn't be able to detect it because it's lower than the actual reading of the laser scanners. But we are having on every corner proximity sensors, as Ronald said, and the 3D cameras, which are also being involved in the detection systems. Okay, so that was just to sum it up, because maybe not everybody understood it well and correctly. But all the questions from Tony here and Moni, we are leaving for the Q&A session at the end of the meeting. Okay.
Maybe if I could touch on this question a bit more, why I explained it all and why it's important. This is because the safety scanner system that the robot has is the safety certified system, which is avoiding all the collisions. All the other additional sensors are just used as an extra input to the safety system. But to answer it directly, does the robot see forklift forks? Yes, it does.
Sorry, Ranel, I had like 15 seconds of losing you. Did you ask ask me a question?
No.
No?
I was
Okay.
just.
Okay.
No.
So I have even more information from the client. It is actually the cycle times that should be met. We want to hear it because we are going to build a real application, so we need to know the times. So if it comes to the screws delivery, sorry for asking once again, but I have seen that someone has turned the Q&A session for a second, and I just want to make sure that you are seeing my screen with the layout with the stations. You'll confirm
I
it,
don't
Ronald.
see it. No, I don't see it at least.
You don't see it. Okay. Just a second. I need to share it. Not yet. Okay. What about now, guys?
Yes. Yes, now.
Yes, it is visible. Okay, perfect. So yes, if it comes to the screws delivery, we said that actually the best way would be if it is, maybe it was good. It was like twice an hour. We need to get the screws twice an hour, Ranel, but every station needs to be supplied with them. We are going to talk about the logic of the mission then. Just keep in mind that we need to go twice in an hour with the screws, and every station needs to be supplied. That's actually the prerequisite of the mission, of the one mission. Tool magazine, it's maybe not tricky, but it's more like this. This mission should be, let's say, uh, made on demand. So actually operator can call the robot when he wants, because of course it's not being scheduled which tools he actually needs in a specific moment. So we need to give the people the chance to pick the right moment the robot to drive in with all the tools. And if it comes to cycle times, I ask the client to count up all the things in a couple of days, and it looks like that: 15 times per shift. Shift is being counted like an 8-hour shift. So one station. So free station, you have like 45 times divided per 8 hours. So it's more likely more than 5 times per hour. Looks like so. If it comes to tools, of course it will be on demand, but the numbers that I told you, that I passed you, are being based on the experience of the clients and the calculation. So we have more like 5 times an hour we need to distribute the tools. Okay.
Let me maybe jump over to the calculation I have prepared or showed for you.
I'm just closing my share screen.
All right. 1 second. Can I share my screen? Okay. Can somebody confirm if the screen is visible?
For me it is. Let's yes. It is visible.
Okay.
Perfect.
Let's zoom in. So Lucas, you sent me these cycle times and numbers before in an email, and I prepared a small calculation that that I usually use for estimating, let's say, the number of robots that would be needed. So what I have filled out in here would be the distances from point to point. In the factory layout that you sent me before, I measured what is the distance, for example, from screw delivery and to screw pickup, so to speak. So I measured all the distances from A to B, etc., and filled them out in here. In the second place, what I have in here is the idle time for transports. I added in here just a default 60 seconds, which would be, let's say, docking to a station and until goods are delivered or not.
Sorry,
It is,
Ranel. Idle time means the time when a robot is just staying in place and not doing an emission, actually. So it's just
yes,
waiting
yes,
for,
yes.
okay, waiting. It's like idle time is waiting time in this case. Okay, okay. Thank you.
Yes, yes, yes. And then we have transport frequencies per hour. So let's say screw delivery, screw pickup 2 times per hour,
Yes,
tool pickup. I calculated to six times
yes,
per hour because you need to
yes,
go both ways.
yes,
So
exactly.
this is kind of the basic calculation that you can always do to estimate how many robots you will exactly need. So if you know the distances, if you know how much it takes for you to stay in place to dock, etc., and you know the speed, then based on that you can calculate just an approximation how many will be needed. So I would say just based on the CAD layout and based on these numbers in here, it can be done with one robot. I would recommend two, but I think the main operation could be started with one robot.
Okay. So it's also very interesting. The same professor I have mentioned already like 20 minutes ago has also told me about AGV and AMR, because obviously we are talking about autonomous mobile robots, which acronym is AMR. He
Mhm.
told me that while calculating the fleet, you've got a number. Let's say it's 0.97. You always round it up one higher. So when from your calculation your calculation, let's say, is basing on an application, and it says at the end the output is 2.28, it means that you
Mhm.
actually need to implement 3 robots to make
Yes,
this possible, because the end.
I will
Oh,
say the same.
yes. So we had something like circa 0.8, yes. So of course we are just rounding it up to 1, and we have
Mhm.
one robot that should actually accomplish our processes within the correct time frames, yes, that we are just
Mhm.
putting on the, let's say, application requirements. Yes, okay, so we've got it. We've got the calculation, we've got the cycle times. So it would be really nice to see actually the fire in the mirror interface. Are you going to share it with us?
Let me show you, and then maybe we can also discuss a bit about
Yeah,
the.
just quick reminder, Ronald has already prepared something what we are calling simulation, but I don't like this word because actually it's a real application, but it's just not yet deployed in the real robot. So we have
Yes.
actually layout that matches the layout I've been sharing with you guys. So you probably see that is the same. Okay, so
Yes. Yes.
go
So
ahead. Go ahead.
this is a simulated robot, just a software tool into which I imported the CAD layout you sent me before. Inside the CAD layout, I just removed a lot of stuff I do not need and added the area where the robots are supposed to drive. And for demo purposes, I have added here, for example, a charging station, and then a position for picking up screws, a position for picking up tools, and then 3 stations, so to speak.
Okay, so basing on the layout, we've got 3 stations. Could you just point them out? So station 1 is of course in the correct place. Station 2 is in the correct place. Station
Yes,
3 is
so
also in the correct place. And yes, station 2, station 3. But
yes, yes.
what I see, are we able to put a zone that would be really good to operate within all the infrastructure of the forklifts, I can say you that it hits almost the
Yes,
station number 2.
yes. For example, when it comes to the forklifts, it is very important, based on what I have seen on the field. If you have forklifts together with autonomous robots inside the factory, then you need to put some order. So, for example, you can see I have all around forbidden zones, for example, right? So if you have forklifts, then for forklifts you can make a dedicated parking places. Let's say something like, just as an example, as a demo, you could have parking places for placing the forklifts on the map. So if this is a forbidden zone for the robot, means that the robot will never go in here.
Okay, so for example, the client goes on the factory floor with a tapes it on the
Hmm.
floor, and then
Yeah.
you are just making it on the interface, and you know that here is a place for a forklift, and the robot knows that he's not he's not allowed to go there because, of course, obviously there could be forklift left. So
Yes.
okay, I got it. I got the idea. Okay.
Yes, and then if you have, for example, you know where the robots are need to drive. So deploying these applications is all about also the traffic management, so to speak. So if you know where the robots need to go and etc., then what you can do is make kind of preferred zones for the robot on the map. So if you have a zone like this, like the green one, means that robot will always do its best to plan a route through this green zone here.
Okay, so actually you are modeling a perfect route, which could be, of course, changed when some obstacles are ahead of it. So
Yes,
okay.
and vice versa. If you have an area with a lot of people walking around, and you will maybe prefer robot. Wait, let me just. You will maybe prefer the robot not to drive in that area, or then you could add something like this in addition.
Okay, so this zone means that you are able actually to drive there, but if you are not, let's say, forced to go there, don't go there.
Yes,
So like something like
yes,
unpreferred. Okay, it's
yes,
actually literally unpreferred zone.
yeah.
Right. Everything's clear. Uh, I've been talking to the client, and he said that he can actually manage the organization of the traffic. Like he wants the robot play a sound and like give some light signals when he
Hmm.
goes to the zone with the forklift. So
Hmm.
if it's not possible, are we able to stack up some zones? So for example, you have put unpreferred, but in the unpreferred zone, I would also like to have a sound and light zone because to have.
Yes, so we have a really nice zone for that. It's called sound and light zone. So if you have an area which in where you would like to play some sounds or indicate the lights around the robot, then let's say this area would be here in the middle, perhaps. Let's just suppose a critical area which you want to show clear indication. Then you could add this yellow zone in here, and now in
Both.
here actually choose.
So are we able to put both of the parameters? Okay, I see we can. So
Yes.
light and sound.
So
He
you have
said,
the lights. The robot will flash different lights around it, and then in our interface, you can actually import your own sounds. So as let's say you import the sound in Polish to say, uh, please move away, or I am
yeah.
driving, for example. Then you
So
can upload it in our interface and then choose it from here.
I have even more interesting story. One of our clients has decided to divide his shifts into a Polish shift, which has included the Polish
Okay.
employees, and the second shift were based on the Ukrainian people. And he wanted to divide also of course, the sounds being played from the robot. And basing on the Modbus registers, he managed to write the simple program that were uh, the Modbus registers were being picked up then in early morning when the shift is starting, and
Mhm.
when the Polish shift is there, the commands were fully Polish. But when it was the Ukrainian shift, let's say, it was fully Ukrainian. So it's really flexible. Like every shift you can like change the application and the purpose for that. So it's very very uh, nice for me.
Yes, yes, definitely. You can really customize
Yeah.
what you would like the robot to do.
Yeah, actually, that was the word that I was missing. Customizing. Yes.
So now you see the robot plan the route on this green
Yeah.
line in here.
Okay. Can we make also a mission live? Because it's so easy to program. It's so flexible. Everyone says so. So let's do it. Maybe right now in like 1 minute.
Yes.
Can I tell you the prerequisites of the first mission if it comes to screws? As I said, it's not on demand. It needs to be done, every 1 hour.
Mm-hmm.
And we need to supply every station. So it needs to go to station 1, then it needs to go to station 2, go to station 3, and at the end, maybe I also forgot to ask you. You told about the forklift place. What about the
Mm-hmm.
robot place, like a parking slot? I'm calling it parking slot. I don't know if it's correct. Maybe staging position would be more correct. But yeah, like a parking also is very intuitive for me. So parking
No,
for the
it's
robot.
totally correct. Usually we have these parking spaces when our another product, Mir Fleet, is involved. So that is intended, for several robots in one factory.
Okay, parking. Okay, perfect.
But I
I
will
got
just
it.
make a robot position in here for parking. So let's say I just need to save this for a moment and refresh to get the parking position as
Available.
well. Yes,
Yes.
yes, yes. So I
Okay,
will
so
just
we are
multiply the
moving.
last one and add here parking.
Okay.
So this will be already just a very simple mission to move between different positions and finally to the
Could we
parking
play it?
position as well.
Could we play
Yes,
it
sure.
and then talk about how we could actually pick up the screws and how we could pick up the
Mhm.
tools? So about picking up the things. Now we are talking generally about the logic, but I want to go into the mechanical details also because I think that we have prepared some nice solutions for that.
Yes, definitely. So this is one of the things I was thinking about as well. If you have basically two options in here, either you are going to use a shelf application, which means that all your screws, etc., are mounted on a rollable shelf, and robot goes under that shelf, picks it up, and delivers it to another location. Um,
Uh,
and
we
then there's another option as well, which will be a static top-mounted module.
and we are going for that because we don't want to increase the footprint. We don't
Mhm,
want top modules. We want a fixed platform that is docking to certain gravity platform,
mhm,
Karakuri. The
mhm,
client wants Karakuri because like it's a low cost automation platform. It's not using any signals, any actuators, any motors, any drives. It's just basic a pure gravity solution. So when the robot docks to the solution, then some things are just popping up straight to the robot and vice versa, so the robot can place some stuff on the platforms. Yes.
mhm.
Okay, so now I can see that the robot has have driven straight to the screws, then goes to the station 1. Now is in at the station 2, has already delivered the goods, and now is going to the station number 3. And we can clearly see that it is really following the green area, which is of course the preferred zone. And if we are talking about the preferred zone, I can see some questions about the maximum speed in the green area. I know that we are going to answer all of the questions at the Q&A session, but when we are in the interface, we need to say that the green area has nothing to do with the speed. It just tells the robot what is the best way to drive from A to B. So there is no maximum speed in the green area. It's the same speed as in the all of the areas that we have created. Am I correct, Ronald, in terms of that?
Yes, yes, and actually, uh, of course, speed depends on which robot is being used, etc. But speed is actually totally configurable inside the interface. So if you have areas where you want to drive faster or slower, then let's say this area you have marked on the floor that the robots are always driving in here. So then you could have here maybe let's say a speed of let's say 1.0, for example, and then you could make another area, let's say in here. Perhaps there's a lot of people walking, and you want to take care to have the robot going a bit slower, for example. You can put here 0.5. And then after you have made this edit, we'll need to save the map. And then the speed changes will take effect when the robot is entering this area over here.
Okay. So the mission, if it comes to the screws, is done and is working as I have postponed to the client, to be honest, because yeah, he was expecting that he is grabbing and picking up the screws, goes to the station 1, 2, 3, and goes to the parking. That's what we actually could see. Okay, now I can see that even if we stack up the zones, it follows the green one as much as he can, actually.
Yes. So yes, the robot is basically, when it is calculating its routes from A to B, he's always trying to find a route that has the lowest cost, right? That with the minimum resources which I can use, what is the fastest way or the best way to reach that destination? And this can be modified slightly with different zones on the map, as you can see.
Okay, so yes, as I can see, screws is done. Now, what about the tools? What about the on-demand something? So how the people could actually, call the robot, like, come on, I need you, come on, I need you.
Yeah, let's say you had here a mission, for example, big screw, right?
Yes.
Let's say just let's make one example.
Like
big screw mission. You can go to pick the screws up, right? And then there are many options. You can have a mission for a big screw and deliver to station 1, and you can have those in separate missions, or you can have the last one as a parameter, for example, where to go to. So you can put in here, for example, where default value, maybe station 1, right?
Okay.
And then I think if there are people working at the stations, etc., then the people could actually have tablets over there which are connected to the robot interface. So as you said, they need to be able to schedule the missions on demand. So they could have a tablet where they could choose a big screw, and then in here choose maybe which station do they want to go.
Could we show a real quick the dashboard that could be created there for to trigger the missions, just to show a map on that and make a button to trigger the missions, just to show how the operator would see actually the interface, because I can see the clients is within the attendance here, so I would like to show him how the operators would be seeing actually and how they would interact with the robot. So simple dashboard. I don't think actually it will take a long time to create it. Really easy. So yeah, map for sure, a map to see and track the robot during the missions, and mission button, of course, to assign a mission. Where are our mission? Big screw, for example. Test is also our mission. We can just yeah.
Then you could have here mission queue in the bottom.
Play and pause button, also very, very important to have.
Yes.
Yeah, looks like a very basic. And you see, like I've been tracking time, like 37 seconds run. Good job. You could start in Formula 1. Nice. Okay.
So then what operators could have, you can make actually user account for operators. So when they log into our interface, then all they will see will be this dashboard only. And from this dashboard, they can able to click, pause the robot, so you can see robot stop moving, play again, the robot continues the mission, and you can see what is the robot currently doing.
Ronald, we have 3 stations. So station 1 has a tablet with a mission, bring me the tools to the station 1. Station 2 has a mission, bring me the tools to the station 2. And of course, it goes on in the station 3. So there is a mission, okay, bring on the tools to my station 3. Correct?
Yes, yes, yes. And there are actually many options. It doesn't need to be tablets. Our robots have, it's basically like an open platform. So you can build your own top modules, etc. But also the software wise, it is open. So if you want, it's possible to make maybe some buttons for the operator. So if physical buttons, so to speak, which are maybe connected to some PL&CEE, etc. So when operator presses a button, then a specific mission is run, for example. So robots have like this kind of open software platform where people can customize really their applications to quite some extent.
Okay. Okay. I think that we are ready with that. So we have analyzed the layout. We have done the yearly calculation of the amount of the robots. We have even put the robot over here to operate, make the map, make the missions, make the dashboard. So now it's time, I guess, for the conclusions. We need to sum up all our choices, beginning from the type of the robot, from the type of the top module, and everything we went through. I would like to have it summed up because in a couple of minutes we are starting our Q&A session. So prepare your
Yes.
keyboards and click as fast as you can, but it needs to make sense. Okay, Ron.
So I guess for summing up, I think it's a really nice application, and it is really perfect for mere robots or autonomous robots in general. You need maximum 60 kilos payload. You need ESD protection, and you need the maximum protection against the forklifts or any other objects that are, let's say, under the safety scanners. So I would say MIR 250 is an excellent choice for this application. When it comes to the calculation of robots required or the charging stations required, etc., I would say that you can start off by one robot, which should really accomplish your cycle times for 2 shifts, if I remember correctly. So one robot should be enough to get started for in here, plus one automatic charging station where the robot can go to charge when it is waiting for a new mission, etc. And in terms of application, which top module they use, like you said, you don't really want to extend the footprint of the robot because it is not such a large area where robot needs to operate and very dynamic, a lot of people. So the smaller footprint you have, the better. So I'm also leaning towards static top-mounted application. And like you mentioned, this Karakuri solution is really excellent and simple because there's not any electrical parts whatsoever, so everything is controlled by gravity. You talk to a station, the boxes roll, the exchange is made, and you drive to another station. So
Yes.
So I think it is an excellent application and actually quite a simple one.
Okay.
I would say.
Okay. Of course, the client needs to make some adjustments and modification in terms of the organization of the factory floor, because people needs to understand that robot actually cooperates with them. So they need to treat him like a normal factory worker, actually pay attention when he drives, and not be like, okay, it can't hit me because it's safety. You need to understand it's a worker, like a normal worker. Just we need to treat it like that. And with this accent, I would like to really thank you, everyone, for attending this meeting. Thank you, Ronald, for this really broad analysis of the case. You were really well prepared. I couldn't find a better co-host of this event. Thank you for that. But don't go. I need you here. We've got this Q&A session coming. So as I could say, okay, guys, you can actually start bombarding the chat. Ronald is ready. I'm ready. So we can go. We are starting to answering the questions. Rather, let me write the question for you. The first one: does the floor within factories and warehouses and magazines areas have to meet a minimum standard?
Okay, that's actually a really good question. So when it comes to the floor where the robots are driving, then it is the most important that it is a solid floor. It is straight. It is without bumps, because our robots they are intended to be driven on solid straight floor. So there shouldn't be more than, I would say, 2 centimeter bumps or holes, so to speak. Another important fact for the floors is the friction between the wheels and the floor, and also that comes from many things. It is affected. The friction is affected by the weight of your payload, by the height of your payload, etc. So I would say that before you totally buy the robot and put the weight on it and start using it, it is always recommended with our global distributors who are there in your countries locally to do a demo run on the site. So, for example, let's say for this application, if we have determined MIR250 will be an excellent choice, etc., then another step, if possible, would be to make a demo run with the MIR250 on site, see how it moves, see how is the floor solutions. So this should be always tested. But in general, if you have in the normal factory floor, let's say concrete or something beton, something similar, then that's the floor we are used to be driving on.
Okay. So now the question from Moni we got, it's actually, can the AI camera be used in this particular case to warn the robot of the obstacles? I see
Um,
that Moni knows already MIR products because as you are going to say, AI camera is a MIR product. And
Moni has a really good point. So we have, let's say, three products. We have the robot, or several robots in the factory. Then we have a fleet, which is a software package for managing all these robots in a factory. And then in addition to that, we have a product called MIR AI camera, which is basically like an add-on to the fleet. So to answer Moni's question, can the AI camera be used to warn the robot of the obstacles? Then the answer is yes. So if you have an area inside your factory where you have constant obstacles, maybe maybe very dynamic, hectic times, things are left here and there, but robot needs to navigate somehow as well, then you can put that area as a robot limit zone and place an AI camera that is overseeing that whole area. And if there is an object placed inside this area, then this zone can be locked, meaning that meaning that the robot will not be able to enter this area.
okay, thanks for that. Now it's the question from Adrian. Thank you guys for the thank you for the feedback. But straight to the question. Yes, we said that there are robots with the dynamic load capacities up to 1,000 kilograms. It's correct. And the question is, do all of them come with the ESD tail protection as a standard, or is it that an extra feature which can be chosen?
So basically, not all of them come with ESD protection. Right now, we have MIR 200 and 250, which come with the ESD choosing option. But for the other robots, we do not have ESD protection, certified protection. That is because the higher payload robots that we have, 500 and 1000, for example, they have not been intended or have not been designed with ESD protection in mind. So for electronic industry right now, I will say 250 is the best option with what we can offer.
Okay. So let's stay online a couple of minutes. Maybe someone has another question for us. If there are not Further questions. What is the working time of the robot on the battery? How long does it take to fully charge? I suspect that Tomasz means one battery of the robot. So we are going to explain this whole process, how it does look. Okay. One battery, Ronald.
Should we take the 250 as an example?
Yes. Yes.
Okay, for the 250, if I remember correctly from top of my head, with full payload, I think it was around 12, 13 hours of delivering goods, so runtime, and charging time was 10 to 90% was 70 minutes, 1 hour more or less.
Yeah.
Yes. And yeah.
Okay, so a very interesting question actually for the people that are not yet very, let's say, into the Mir products. When we talk about Mir 250, does the 250 mean that the load of 250 kilograms, or am I wrong? No, Adrian, you are completely right. So every single number that stays after the MIR acronym means actually the payload. I think the Mir is actually doing the same thing that the Universal Robots is doing. So when they are releasing a robot that is named UR16, it actually means that is the cobotic arm universal robot which can handle up to 16 kilograms. So Mir is the same, I guess. So Ronald, sorry for going out, but also wanted
You
to
are
answer
absolutely
at least one
correct.
question. At least one question for me. Okay. Yes, Adrian. You got it right.
Yes, it is quite simple to navigate a portfolio like this, and it's
Yeah.
the same like you are doing.
Okay. Do Mir products come with any spurs, or are these purchased afters? Spares like Tony, do you mean spare parts like some spare parts on stock? Yes. Okay.
Okay,
So
I
Ronald,
think
what
I will
is
take this
Yeah.
question. Yes. So for the robots, when it comes to spare parts, there isn't actually a part that you would need to purchase together with the robot just to have as a spare for the robot. Of course, there are maybe two things to keep in mind that might need replacement over time. First one would be the battery. If you want a spare battery, let's say when it's 250, you will need to buy a spare from your local distributor. Another thing would be the wheels. So wheels are basically the only thing that is being used over time. I will say that they need to be checked every couple of months for any wear and tear and replaced when needed. I would say that the replacement of wheels might come in mind maybe after 2-3 years.
Yeah, but of course it
Depends on the
depends
floor, of
really
course.
highly, yes, on the floor and the condition of the floor. But yeah, Tony
Exactly.
is thinking about the parts that could be worn after some time, of course, like battery, of course, of the capacity of the battery, and of course of the wheels. It's highly depends of the application. I really don't like saying that depends on the application because it really says nothing. But in this case, it says everything. Really, it depends on the condition of the floor, on really how the floor look like. So here we need to think about it.
So to
Okay, next.
answer this question straight away, they would need to be purchased separately.
Okay, so I'm taking the next questions from the Tomasz. I can see. Can I schedule the robot's arrival at a specific time? Of course, you can do it in a specific time. I actually were playing with the Mirror robots a lot, and I have seen they have a really good made up REST API documentation. And of course, the API is very good. So you can actually trigger a specific mission with some in time interval, or as you said, in a specific time frames, but you would need to connect the robot with external control device. It could be an IoT device, it could be a PLC, it could be something that can handle a logic and then trigger something. So it's completely doable, I would say, and I have seen it a lot of times. For example, we are making now application when the operator clicks on the tablet when it's up to him, where it's also up to him because he chooses that. But we have seen a fully autonomous applications where actually the computer chooses based on some ERP systems callouts, and he is actually choosing the robot and the mission and etc. So it's fully not only an autonomous robot, but also let's say an autonomous application. But today we were talking more about the collaborative with people and robots. So the case were dedicated to that. But of course, it's possible. Okay, Randall, next to you. Does the Mir robot use any oil?
Yes, there is oil inside the gearboxes or the motors themselves, but it's completely sealed. There is no oil that you need to replace. Let's say for the industrial arms, I think it's, if I'm not mistaken, every 6 months perhaps, that you need to completely change the oil inside the arms. Mir robot has nothing of that. So you don't have to need to replace any oil or check oil levels or anything like this. No.
Okay. Okay. Okay, we are finished with all the questions for now. Let's see, maybe one additional minute if someone has got something in his mind. How do I update software, firmware if necessary?
Really good question. Software updates are coming out from your side very regularly. In addition to that, we have like a stable versions that we recommend certain clients to stay on depending on the application, etc. When a software update is released, then this is sent out to all of our partners all across the world. So let's say ProCobot in Poland will receive a note that there is a new software, what was changed, etc. And then it really depends. Either ProCobot decides to update your software, or they will send you the software file, which can be then just uploaded through our interface. So it will be just a file to put in the interface. Goes the same for the fleet and the robots.
Yeah. Okay. Okay, guys, thank you for so many questions. Now we are going to wait a little bit. If there won't appear any other questions, we are going to finish this event, which of course will be revived after the Christmas, after the New Year's Eve, and we are going to grab another client, another case, different application. The only same thing will be me and Ronald. So, and the name of the series.
Yes. I think
Okay.
in general it's nice that you are doing this kind of a concept. So it maybe gives a
Yeah.
broader spectrum what is involved before the purchasing and what to consider,
Yeah.
etc.
Yeah. 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 Yeah, I think that is great that the people that are with us today, I hope that you are going to be with us also in the next episode. Prepare another set of questions and be prepared to be approached by another application. And this time we are not going to use Karakuri, but I'm not going to spoil anything because no, can't do that. Okay.
In addition to that, if any of you listening or participating in this meeting, if you are interested in mobile autonomous robots and would be interested to share your case story or provide maybe your layout or ask questions, then I guess feel free to reach out to Lucas.
Yep. I'm just going to leave my mail in chat section. Of course, it's everywhere, but just in terms of something. Okay, guys.
I will
No
get
further
mine as well.
questions. And Ronald also is posting his. So I would really like to thank you for attendance. I didn't expect that so many people are going to be interested in this event. And what I would like to wish you is really happy and family Christmas. And the times are hard, but we are going to make it together. So stay healthy, and we see each other in the next year. Thank you, Ronald, once again.
Thank you for joining.
Kamil, yes, this video will be available. Okay. It will be on YouTube. We are going to post it. Maybe we are going to send some mails when it's recorded and posted. Okay. Never mind. Thank you once again, and we see each other in 2021. Bye. Thank you.
Bye bye.
Bye.